Alright everyone, this is 6.1, the Polygon angle sum theorems. Okay, your due now is to name as many polygons as you can. Alright, the one that we should be most familiar with, that we've worked with the past few months, is a triangle. Okay, we go on to a four-sided figure, would be a quadrilateral. And why don't you jot down as many as you can think of beyond these two, and I'll check them when you submit. Vocabulary terms, okay, a polygon, just a plain old polygon, is a plane figure with at least 3 straight sides and angles. Now there's different types of polygons. Feel free to pause the video if you need to jot down your definitions. An equilateral polygon is a polygon with all sides congruent. Okay. Equiangular polygon is a polygon with all angles congruent. Easy enough because the term angle is within the name. And a regular polygon is a polygon that is equilateral and equiangular. Okay. Now it says label the following polygons as regular, equiangular, or equilateral. Well, this one, the first image, has sides only, equal sides, which is equilateral. Okay, your next one is all angles, so equiangular. And your last one is sides and angles. Okay, which is considered regular. Okay, the first new theorem that we're going to learn is the Polygon angle sum theorem. So the sum of the measures of the interior angles of an n-sided polygon, which is also known as an n-gon, right? N is just a variable for right now. It could be 3 sides, could be 4 sides, could be 5 sides. We don't know, okay, until we're given the image. So what you're going to use is n minus 2 times 180, okay? So that's going to tell you how many or how much the sum of the measures of the interior angles are of a triangle. Okay, so for our example, we have a triangle and n is 3, right? We have 3 sides. Okay, so this becomes 3 minus 2 times 180. Now we're going back to PEMDAS, you know, you do your parentheses first, so 3 minus 2 is 1, and 1 times 180 is 180. So we know that all three angles, within a triangle will add up to 180 degrees. Okay, and notice the only thing we plug in for is n equals 3 for n. Okay. Some polygon angle sum theorem practice. All right, we'll take a look. The first one we have is a quadrilateral, right? In this case, it looks like a square. So n is going to be equal to 4. So to find out the sum, okay, what do? N minus 2 times 180. So this becomes 4 minus 2 times 180. 4 minus 2 is 2. And 2 times 180 is 360. So the sum of the interior angles of a quadrilateral is 360 degrees. All right, here you have a pentagon, which is a 5-sided figure. So 5 minus 2 times 180. Here you get 3 times 180. Okay, and if 2 times 180 is 360, 3 times 180 is 540. Okay, so if you were to look at your next two, why don't you try these on your own? This time n is equal to 6. Okay, and in your next one, n is equal to 7. So why don't I set up the first one for you? 6 minus 2 times 180. You need that up for you. Okay, and that's because n equals 6, and then try the same for 7. All right, now we'll check your answers when you submit your work. Okay, some more polygon angle sum theorem. Okay, it says, what is the measure of angle y in the pentagon TODAY, pentagon today? So it says, use the polygon angle sum theorem for n equals 5. All right, so if we look, we have 5 sides. So here, n minus 2 times 180 becomes 5 minus 2 times 180, which is really 3 times 180. Okay, and 3 times 180, we said on the previous page, is 540. So that's the sum of all of the angles. Okay, but we have 4 givens, but we are missing the measure of angle y, which is right here. So what we should do is, first we need to know that this is a 90-degree angle, right? It's a right angle, so place a 90 next to your box. And now we're going to add up 90 plus 110 plus 120 plus 150 plus the measure of angle y. And that needs to equal 540 degrees. Okay, so if we are to combine like terms, all of these constants can be added together. So the measure of angle y plus 90 plus 110 is 200, and 120 plus 150 is 270, and 200 plus 270 makes 470. Now this is a normal two-step equation. Subtract 470 from both sides, and the measure of angle y is equal to 70 degrees. Okay. Here's another go. It says, what is the measure of angle G, and this time the quadrilateral? So n equals 4 for 4 sides. Okay, so we have 4 minus 2 times 180, which is really 2 times 180, which is 360. So we have 120, 85, 53, and then the measure of angle G, which is right here, which we don't know. Okay, so the measure of angle G plus 120 plus 85 plus 53 is going to equal 360 degrees. Combine your like terms, 120 plus 85 plus 53. So type those in, 120 plus 85 plus 53. And we get a total of 258, which is equal to 360. I'm going to subtract my 258 from both sides, and the measure of angle G is equal to 360 minus 258, which is 102 degrees. Okay. Now, there's another theorem for today called the corollary to the angle sum theorem. The measure of each interior angle of an n-gon or an n-sided polygon, and there's a word that we're really missing in here, and I'm going to put 4 equiangular or regular polygons. Okay. Then the measure of each angle is going to be n minus 2 times 180, but this time we're going to divide it by n. So for example, we have a triangle with 3 sides. So n is 3. 3 minus 2 times 180 over 3. 3 minus 2 is 1. Whoops. It's 1 times 180 divided by 3. I'm going to bring my work up here. 1 times 180 is 180, and 180 divided by 3 is 60. So, if this triangle is equiangular or regular, then each of the angles on the inside, all 3 of them, should be 60 degrees. Because 60 plus 60 plus 60 equals 180. Okay. So, the common housefly, Musca domestica, has eyes that consist of approximately 4,000 facets. Each facet is a regular hexagon. Very important. Regular hexagon. What is the measure of each interior angle? So we're going to have to use our brand new corollary to the angle sum theorem. Okay? So if there's a hexagon, we know that there is 6 sides. Okay? So this becomes, instead of n minus 2 times 180 over n, this becomes 6 minus 2 times 180 over n. Okay, I'm going to bring my work back up. Equals 6 minus 2 is 4 times 180 over 6. Excuse me, this should be 6. Okay. So if we plugged in 4 times 180 into our calculators, we would get 720 divided by 6. And if you take 720 and divide it by 6, that equals 120 degrees. Okay, so each angle inside of a regular hexagon is going to be 120 degrees. Okay, and all those added together gives you 720. Okay, what is the sum of the interior angle measures of an 11-gon? The sum of the interior angles. In the second question, it says, what is the measure of each interior angle of a 12-gon or a dodecagon? Okay, so n equals 11 for this one, n equals 12 for this one, and you're going to plug them into the following. Sum of the interiors is just n minus 2 times 180. But the sum, or the measure of each interior, is n minus 2 times 180 divided by n. So plug these values in for n and tell me what you get. Thanks for watching. Don't forget to check in for attendance and submit your